Hello ladies and gentlemen, so today we're going to look at factoring using special cases. This is the last kind of factoring we're going to look at. Some notes that you're going to want to have, a calculator, pen or a pencil also. So steps to having special cases. What you're going to want to do. First, just like last time, you're going to want to identify A, B, and C in the polynomial. If there is no B, we can assume B is equal to 0. So that means if there would be an x squared and just a number, B is going to be 0 then. Multiply A by C, find the factors of AC. So basically we're going to do the AC method exactly again. So here's some examples. Please make sure you rewrite this should be 36. Accident by me. So I'm going to find 36. A times C, right? 1 times 36. 36. Some numbers that I can have for 36. But add together, so two numbers multiplied to give me 36. That add together to give me 12. 6 and 6, right? That'll give us 12. So I can make this 1x squared plus 6x plus 6x plus 36. So if I box that, I'm going to get an x and an x going across, right? X times 6x, x times 6 should give us 6x. X times 6 is going to give us 6x, and 6 times 6 is 36. So I can write this as x plus 6, x plus 6. But remember, x plus 6 times x plus 6 is technically x plus 6 squared. Not much different than AC method. The only thing that these are going to come out with is you're going to see that you're going to get the same thing twice. It's possible. Let's try this one then. So I need two numbers that multiplied to give me 49. 1 times 49 is 49. And I need a negative 14 when I add them. Negative 7 and negative 7, right? That should give us 49. So I can write this as 1x squared minus 7x plus 49. Let's draw a box here. There we go. X and x will give us x squared. X times negative 7 will give me negative 7x. And then a negative 7 there. So we should have x minus 7, which is technically x minus 7 squared. Not too hard, right? Now, difference of two squares. This is what these are called. They're just a little different. Notice how there's no b term. So I know b must be 0z. So I need to find my AC of negative 9. And I need the two numbers multiplied together to give me negative 9, but add to give me 0. So two numbers multiplied to give me negative 9. So one's going to be positive, one's going to be negative. What about negative 3 and 3? Right? That's going to add together, give me 0. So z squared minus 3z plus 3z minus 9. Give myself a box here. Z squared, 3z, well that's negative 3z. 3z and negative 9. Z and a z going this way. Z times negative 3 will give me negative 3z. Negative 3 times 3 will give me negative 9. So I can write this as z minus 3, z plus 3. Let's try this one also. So notice my b is 0. So I need negative 16 for my AC. Two numbers that multiply together to give me 0. Or that multiply to give me negative 16, but add to give me 0. What about negative 4 and 4? That would work, right? S squared minus 4s plus 4s minus 16. Let's box that. Okay, s squared minus 4s, positive 4s, negative 16. Fill in our outsides here. that. So we're going to have s minus 4, s plus 4. Now, notice how both of these problems had opposite signs in the inside. And notice how each time our numbers have been the square root of that number. Good thing to pay attention to. That's actually, you can even bypass the box on these ones and go further with this. So let's try this one. So we're going to use this. Instead of using AC, we're just going to factor. So I'm going to have my two parentheses here. One with a plus inside and one with a minus. Notice how there's a 16 with this. So it's not just going to be x and x in the front. There's going to be a number with that x. But let's do, it's a perfect square. So what's the square root of 16? 4, right? So there's going to be 4x on the front. And then what's the square root of 81? 9. That's pretty simple. If you don't want to use the perfect square, or if you don't want to use the square or the box, you can use difference of two squares using this method, thinking the square roots and putting them where they are. We'll do a few more examples of this kind in class. But that's the end of this video. See you later, Sabers!